Hey guys, how's it going? This is Siri and I'm back with another PyTorch video. And this video is going to be mostly focusing on tabular data. We've already focused on images and volumetric data, and now we're going to be spreading our wings into tabular data as well. So this process is actually going to be broken up into two parts. So in this video, we're just going to be talking about how to load the data and what kind of different values we can store. Because we're not just going to be looking at the actual titles of the columns, but we're going to be looking at whether it's continuous, whether it's ordinal, or whether it's categorical. So you can look forward to that in this video. But in the next video, we're going to be talking about one-hot encoding. So that's going to really help us encode our data into a form in which we want it to be in. And so, yeah, that's what we're going to be focusing on in the next couple of videos. Okay, so let's get started, shall we? So we're going to be talking about tabular data. Okay. So it's actually one of the most common types of data. Okay, you might expect it, like how when you see like a spreadsheet, you see some rows and columns and things like that. It's basically what you think it is. It's a table, and it might be stored in like a CSV file or, something on a database or something like that. Okay, so like I said, you'll have rows and you'll have columns, and with each row being like a different sample. So if you have some data and you have one sample and you have another sample and you have another sample, each of those samples is going to be represented on a different row. And this might be news for you and it might not be. So, okay, so each of the different samples are probably not directly related to each other. Okay, so they're independent from one another, at least in the one we're going to be discussing. And you might ask, well, how might they be related to each other? Is that even possible? Well, one form of relationship the samples could have with each other, but we're not going to be discussing in this video, we are going to be discussing it in a future video, is time series. And in time series, the different samples are related to each other based on how much time has passed. Okay, so yeah, that's how the samples might be related to each other, but in most general cases that aren't, time series, or maybe there are other cases, but mostly you'll see, or you'll encounter data samples which are not related to each other. So for example, you might have, a patient's health record. Okay, one patient's health records are not going to be, they're not going to impact another person's health records, right? Or it might not get influenced by another person's health records, right? So that's what I mean by not related to each other, okay? So, if this tabular data, or, data table, if you will, if you, like, all that data might not be homogeneous, right? Or homogeneous, right? Because you might have different values, different categorical values that are associated with one data sample. You might have multiple features, multiple characteristics of one data sample, and all those different characteristics are probably different columns on your data table. Okay, so maybe you're not just seeing numbers, maybe you're seeing, color or age or, disease name or place of birth or city, or, these all might be different columns that you might encounter that are associated with each data sample. Okay? But the thing is, neural networks only take numbers. That's what we've learned. So how would it take in color or, you know, like age, how would it take in all these things? Well, that's where one-hot-encoding comes into the picture, which we're going to be discussing in the next video, not this one. Right, you need a way to represent that data in numbers, so that's what that's all about. And, you know, tensors are the core data structure once again, so that's what we'll be using. And eventually we're gonna need to be able to convert that to a PyTorch tensor, okay? Because tensors are the way we do all these computations. We get from the input we want. We get from the input we have to the output that we want, and in the process, it learns the different features based on the different computations that it does. Okay, so we could potentially be using 3 different tools for this. One is the Python CSV module. So that just allows us to work with CSV files, and yeah. Another one is Numpy, which is just a multi-dimensional array library, so it allows us to work with basically tensors, except you don't call them tensors. You call them ND arrays, or Numpy arrays. Okay, and another one is probably the most common with, you know, tabular data, which is pandas. And the reason why it's so popular is because it's basically designed for that. You have there are like data frame objects, there are series, and you know, it's just really great if you want to deal with tabular data. You can easily visualize what's going on, you can see the different columns, you can see the different rows and whatnot. But if you've watched my previous videos, you'll notice that I'm not using the more, you know, expected library that you would think, because I want to stay consistent with all the different videos and all the different types of data that we're using. And so introducing a new library every time, you know, I just didn't want to do that. So it is the most Pandas is the most popular, but we're not going to be using it. Like I said, we're going to be using Image.io. Okay. Great. So, and we can use Numpy with PyTorch, right, because of that interoperability, and the way it's nicely compatible with each other. You can convert between one to the other, and you know, you can convert from Numpy arrays to PyTorch tensors, and vice versa, and the other way around. Okay, so let's try this. Okay, let's experiment with a dataset, and we're gonna be dealing with the wine quality dataset. Okay, so I'm pretty sure you can download this if you search for it. So you should just search for like the name of the CSV, because I didn't change it. So if you search for it as it is and as I show it, I think you should get some results that you can use. Okay, so let's first import Numpy as NP, so that's how we're going to be referring to Numpy. And let's import CSV. Okay, and we're using CSV because it's just a regular, you know, a Python module. So yeah, okay. And let's say our wine path. Once again, I'm not gonna be really using a path because it's in the same spot, unless it's not, in which I'll have to actually pause the video and put it in the right spot. Okay, so wine quality.csv. Okay, wine quality white. Okay, and wine quality, just wine Q, Numpy. So let's convert this CSV file. So what's happening here? Okay, so here we're converting CSV file to Numpy, and CSV is just comma separated values. So let's write that here, comma separated values, and it's exactly what you think it is. They're just values and that are separated by commas. So if you'll have different rows being different samples once again, but the commas separate the different columns and the different attributes for each row and sample. Okay, so it should be pretty easy, right, to convert to a NumPy array. Okay, so np.load text. So yeah, it's converting the text to numbers here, but it's going to be a NumPy array. So let's pass in the path. Let's set our dtype to an np.float float32. And np.float32 is basically just like float 32, except like if you have a lot of them, it's going to be a lot quicker than if you just used a regular Python float. So that's why we use that. And also you can't pass in a regular float. You need to do an np.float. Okay, so the delimiter, and skip rows. Okay, and we'll talk about why in a second. Okay. So yeah, the delimiter is used to separate the values in each row. Okay, so you know where one sample starts and one sample ends. So, okay, and the first line should not be read. It should be skipped because we don't want that to be in our array, because it just contains the column names and not the actual value. Okay, so the first row, first row just contains the name of the column, not the value. Columns. Okay, great. So let's print that. File not found? Okay, I'll be back in just a moment, you guys. Okay, I'm back, and everything's where it should be. So now when we run it, we get a regular NumPy array. Okay, let's check out the type. First let's print this, and let's also check out the type of one-q. NumPy ND array. Okay, so just as we expected. Okay, great. So let's create a variable. Okay, so next we're going to be creating a variable to hold our columns. Okay, and let's just call that call list. Okay, and csv.reader, which just looks at our CSV. We're going to be opening our one path. Okay, and the other argument we should pass in is the delimiter, like we did last time. Okay, so let's check out the shape. Line quality dot shape, and let's also check out the data type. Okay, D type. So if in NumPy it's going to be D type, if you want to just do it in Python, it's type. Okay, and that's going to be a function like we did here, or built-in method, built-in function. Okay. So let's run that. Okay, obviously, it's Numpy, because that's the variable we created, right? Yeah, so we're looking at the shape of this thing that we just printed out. So we have, we have these many rows, and we have 12 columns. So what does that tell us? We have these many data samples, and we have 12 columns, 12 attributes, 12 characteristics of for each of those samples. So now what are those columns? What are those characteristics that we're talking about? So let's print out column list. Okay, so that's what we did here. Yeah, and we printed it out. Okay, fixed acidity. These are the characteristics for, the wine, and you would expect it to be something like this, right? Volatile acidity, citric acid, residual sugar, density, pH, alcohol quality. Okay, a lot of chemistry / wine stuff, right? Okay, great. So let's convert this to a PyTorch tensor now. How do we do that? So from Numpy array to PyTorch tensor. Okay. So wine EQ. So this is our final one. Fine. Actually, it's not wine EQ. It's just wine Q, standing for quality. Let's torch. Okay, go on. Torch, and the function for that is from Numpy. We've done this in like previous videos as well. So, like the basic Numpy, like data to Numpy array to PyTorch tensor. But in, real world settings, it's not going to be this easy, because we don't have the data, in the form that we want it all the time. But we're grateful to have the data in a good CSV format, and so that's why we can do this right now. Okay, so torch.from Numpy, and let's pass in our wine quality Numpy. Okay, and let's print out the shape, and let's print out the dtype. We didn't import torch. Okay, let's do it here. Okay, same here, except instead of an NP, instead of, you see np.float, you get a torch.float. Okay, so that's that conversion. And okay, so we're basically done with that same simple process, right? Okay, so now let's talk about the different types of data you might encounter. And it has to be one of the three that I'm going to mention if it's, tabular data like this. Oh, actually, we didn't use image IO. Okay. Okay. We didn't use image IO. Sorry about the confusion. We just used Numpy, and we didn't use pandas, actually. Okay. But I will mention that it's great for tabular data. Okay. Great. So what was I saying? I was saying that there are 3 types of values that you're gonna encounter. Okay, 3 types of data in machine learning. Okay, and So these can be continuous. Continuous. The other one is ordinal. And the third one is categorical. Okay, categorical values. They're all values, right? They're all information that we're dealing with. And we're just trying to make the best analysis that we can with the data that we have. Okay? And these are the different ways in which we can pass in numerical data into our network. Okay, so we're probably going to have data that isn't actually for images. Okay, for images it might be different. Okay, I'm just talking about tabular data here. Yeah. Okay. So for continuous values, order matters. Okay, and we'll be more specific. Well, what do you mean order matters? In what context? Okay, we'll talk about that. Okay, order matters. Okay, I'm just going to be listing it out right now, though. Order matters, and the difference between them does too. Difference between them matters. Okay, so what do I mean? So if you have, you probably came across like regression as one of the machine learning tasks. If you haven't, that's okay too. So you have like an x-axis and a y-axis, and I mean, the way you represent it is obviously different, but the way you visualize it is like this. Right? So you have, it's like a best fit line, essentially. You have your points all scattered on the graph, and it looks like a line, but, it's kind of fuzzy. And then you draw the best fit line, So for like a house regression task, okay? Example, it's like a house price regression problem, okay? Like house prices, okay? First of all, the order matters, meaning that, to the model, like the fact that a house is, I don't know, like 500K versus like 900K, or, or anything in between, like, it makes a difference. The way the model is gonna learn, is immensely influenced by that difference, right? By that difference, and like the order, like you have, like they're continuous values, like on the graph you see a continuous value, and the output should be along that like line. And so yeah, that's what I mean by continuous. So for time series, although there is a difference between like 8 o'clock and 10 o'clock, you can't necessarily say that, 10 o'clock is like, bigger, or like it's twice as late as, I mean, like a little bit later, 2 hours late than 8 o'clock. It's not logical to do that. Okay, so it's just an interval. Okay, the difference matters, but you can't make conclusions that like, 5 o'clock is like, or like 10 o'clock is twice as late as 5 o'clock. That's not the relationship between the values. So yeah, that's a good way to phrase it. Like, like the 3 types of data really tell you the relationship between the values you see, right? So, ordinal values here. So, yeah, order matters here, but the difference between them doesn't. Does not matter. Okay, what's a good example of this? Well, if you had data from like a fast food restaurant, right? Or fast food place, you might have like a small shake, a medium one, and a large, right? Yeah, order matters, right? If you're analyzing that data and asking your model to do that. But it's not saying that like, oh, the large is like this much bigger than the medium, or the medium is this much bigger than the small. That difference is like, we don't know that, so like it doesn't matter. Okay, so an example is like small, medium, large. Okay, and also going back to continuous values, the difference between them does matter. And you know, it's most likely like if you have units, and if you're counting, like, hey, this is 4, this is 6, this is 7, this is 9, the difference between them matters, okay? It means something, okay? And it's important. So most likely, if you have units, and if it's a counting value, then it's most likely, you know, continuous. So, but here, order does not order matters, right? We need to know that a small is smaller than a large, and a small is smaller than a medium, but we don't need to know how much. And that how much tells us the difference, okay? Okay, great. So what about categorical values? Here, order doesn't matter, and, you know, there's no real difference, okay? So order does not matter. Difference does not matter. Okay, so if you have blue, and if you have green, and if you have red, and if you have like, okay, those can be categorical values. Or maybe you have like you know, the city, like which city you're in, like Boston, New York, or like New York City, or like, you know, whatever, right? So you have to assign like a numerical value to it, right? But whatever value you pick, it doesn't really matter. I mean, yeah, it doesn't really matter. Like, there's no real, you know, even though it's a number and numbers have relationships with each other, these categorical values don't. Like, if you have, for example, okay, if you have, okay, it doesn't work here, but, you know, like, if you have marbles, okay, I'm not talking about like the color channels, you know, I'm not talking about like red, blue, green, like I can't think of any other example right now, but like, you know, if you're analyzing marbles, okay, and one of them's like purple, one of them is, you know, like green, one of them's, I don't know, pink, right? The number that you assign doesn't matter. It doesn't matter if you assign 2 to purple and 4 to whatever other color I was talking about, green, because that's not the relationship colors have with each other. Okay, so that's what I mean by categorical values. Okay? Or, you know, benign or malignant cancers, right? It doesn't matter if you assign 0 to benign or 1 to malignant. I mean, like, there is a convention, obviously, that people use, but, you know, the values that you pick for them don't really matter as long as you know that, hey, 0 is benign and 0.01 is malignant, right? Okay. Great. And the reason I bring this up is because we need to know what kind of values and what kind of data we're dealing with, for tabular data. And so why do we need to know that? Well, we need to know that because we need to convert this data to numbers, and depending on whether it's continuous, depending on whether it's ordinal, depending on whether it's categorical, we can figure out whether we need to use one-hot encoding or some other method. Okay, so let's make this clear. Type of data tells you whether or not you need one-hot encoding. Okay. Whether or not you need one-hot encoding. Okay, we can just put this all in one line. I was just worried if... Okay, so that's why I bring this up, and we'll talk about one-hot encoding next time. Okay, I hope you learned something new today. Yeah, I certainly had fun, and I certainly enjoyed it. But yeah, don't forget to like, comment, and subscribe, and I'll see you in my next video. Thank you so much.